Okay, now we turn our attention to differentiation. At the end of this video, you understand the basics of differentiation, the simple tasks of differentiation. Okay, let us look at first how do you differentiate. All right, you will see that most of the equations, this is the general rule for most of the equation, be it linear, be it quadratic, cubic, or whatever the type of equation. You have the general equation. Let me highlight the general formula, which is this one. We'll see the other rules, but if you have x to the power of something, maybe it's x to the power of 5, x to the power of 4, yes, what you do is simply bring down your 5, then multiply by the x to the power 5 minus 1. That's how you differentiate. We'll have other rules like when it's multiplication, but face to face with a term in terms of x, it can be in terms of v, in terms of c, in terms of u, it doesn't matter. So to make sure that we confirm that one is a conformation, this one means the derivative. Find the derivative of x. Remember, x is x to the power 1, so we simply bring the 1 here, then x 1 minus 1, like this. It's like this. The hidden part, we have our x here, then 1 minus 1. 1 minus 1 is 0. Any number to the power 0 is 1. So our final answer still will be 1. Right. Let us look at the rules, the different rules. But now we know how to differentiate a term. This is for just a term, x to the power of something, v to the power of something, or things like that. All right. Let us continue to see other rules. Okay, we have different rules of differentiation, or we have what have been proven about differentiation. Right, the constant rule, this one is the easiest of all. The differentiation of a constant brings a 0. How does it bring a 0? Let's see. Let me find a little space to see how it brings a 0. I am sure most of you already know it, but let me just highlight. Remember, let's say we have a constant. Let's say c, like in this case. Right. Think of every term as a term that contains an x. In this case, if you want to include an x, because we know how to differentiate x to the power n, but here we don't have an n. Let's try to introduce an, we don't have an x. Let's try to introduce our x. We have x here to the power of what? To the power of 0. Right. So using the previous rule, which says you bring the power down, the power of x down, then you subtract 1. First of all, the power of x is 0. We bring 0 down, multiplied by c x, then 0 minus 1. Alright, so any number multiplied by 0, this term is being multiplied by 0, which brings a 0. So the differentiation of any constant gives us a 0. You differentiate 10, you differentiate 900, you differentiate 2 million, you get a 0. That was our first easy rule. Let's go to the next one. The linear function rule. the linear function rule. All right, as you can see, let's say you have a function like this one. First of all, a is a constant, so we get a 0. Right, we haven't yet seen this rule, but maybe it's important now that we talk about it. If you have two terms like this which are adding, I think we will have the rule as we progress, but a is a constant and bx is the linear function, right? If you have something like this, a plus bx, or two functions, maybe x squared plus 2x, you integrate, you differentiate x squared, then you add to the integral of 2x. It's the same as in this case. We integrate, we differentiate, sorry about that, this one, then we add to the differential of this one. But a here is a constant. The differentiation of a constant is a 0. Differentiation here, this is x to the power 1, is a 1. So we are left with only b. We're also going to see why we have so many ways of proving why we got b here. You can either think of this one as a product, which we are going to see as we continue, or you can just say you factor out this b and integrate this one. It's the same as this a. You can factor out this a and integrate x to the power 0. Differentiate x to the power 0. Sorry for that confusion again. All right. So this is how you deal with it. We have also an example here. The differentiation of this one is 0. Then here, the differentiation is a 6. So the final answer becomes 6, since we are adding this one plus 0 plus 6 is equal to 6. All right, we continue to the next row, which should be row number 3. All right, what do we have here? The power function rule. This one we've already seen it from the first slide, if you want to remember, but let's just have a look at it. The integral of a x to the power. All right, let us just put the topic in the picture like this. All right, the integral of the power function for a x to the power n. Remember, this a is a constant. By product rule, and we're going to talk about product rule, don't worry about it. By product rule, we are going to see that the next thing we have is just the integral of x to the power n. And also remember, the integral is like this: d, then dx, like this, like this. Then we'll have our term here in the dotted lines, in the bracket. We have our term here. It can be, mostly it's y. So it's with respect to x, which means in the simplest terms, you differentiate only the terms with an x, if you want to think of it that way. But in a case where there's just a constant, our term in x is x to the power 0. So again, you differentiate only the terms with x and you get your answer, because it's with respect, or let me say, you differentiate only the terms with a, where you are told with respect to. If you are told with respect to y, you differentiate only the terms with respect to what? To y. With respect to v, you do the same. So as you can see here, we brought down our n, which is this one. Then x, n minus 1, nothing done to a, since it doesn't contain a term in x. Same applies to 4x. Here they've just shown proof of what we did the other time. 4x to the power 0, which is 1 minus 1, and we get our 4. Squared here, bring your 2 down. 2 multiplied by 4, 8. 2 minus 1, 1. Then we get our 8x. Then item 3, bring your minus 2 here. Minus 2 multiplied by 4, we get minus 8. Minus 2 minus 1, we get minus 3. So it becomes 8x minus 3, right? We continue to the sum difference rule. All right, we've already talked about this one. I have two functions. Let me just highlight the functions. If f of x and g of x. What you do is you differentiate f of x with respect to x and add or subtract with the differential of gx with respect to x. This is your y. So the integral is dy dx, or you can think of it. Let me just write just behind that one, d dx derive with respect to x. What should I derive with respect to x? Y. Like this. So y is f of x plus or minus g of x. So you derive f of x with respect to x and add or subtract g of x with respect to x. So it's first function plus derivative of first function plus derivative of second function. All right. We have a situation where y is the sum or difference of two or more functions. Then you differentiate. You do the same also. Let's say I'm writing at the top of the page. Let's say plus or minus. Let me put a v of x. Like this. You are just going to differentiate v of x and add to the, here we're going to have plus or minus g, then v of x, just like this. Then dx, just like this. So that's what we were going to do. Let me see if you are not leaving something out here. And this one is just a proof of the rule we just did. 2x here. We differentiate this one by bringing the 2 to have a 4 here. x1 minus 1, we have 4x here. Then 3x, we bring the 1 here. 1 times 3 is a 3. X to the power 1 minus 1 is x to the power 0, which is a 1. We have our 3 here. Then for the 5, it's the same thing. All right. Let us continue on the next video. Please subscribe to our channel. We're going to be posting more videos. Even the university guys, we're going to be posting videos about university stuff. So please subscribe to our channel to see more videos like